Good evening, friends. Welcome to ESN Academy. And we are discussing embedded programming as a part of embedded system programming. And in the last few sessions, we discussed about how to connect LED and 7-segment along with the microcontroller. And on today's session 5. On this session, we are going to discuss about another important device that's called switch. So if you use LED and 7-segment for output, and we are going to use a switch for input. And as usual, there'll be a small trick will be there. While starting, there'll be a small issues with switches. But once you come across and could write a function, then you can able to handle switches very well. This is a very, very important input to the system. So don't leave the thing just like that. That's a quite important concept. But as I said, you'll listen to this lecture now and see this, whatever I'm giving the demos. When you try it out, if you have a doubt, you can attend another lecture also. It doesn't matter. Okay, that's the advantage of this course. Till you understand, you can be with us. There's nothing called no hurry or anything. Okay, so let us first get into the board and discuss about the concepts one by one. So the trick is, see, if you take a microcontroller, there are 4 devices we connect them directly. One is LED. Second one is 7-segment. And third one is dot matrix. Same way, the input we connect switch. Then we connect keypad. These are all the easiest devices which you can connect directly and start working. So later we are going to discuss about how do we connect the devices through controller. There are 2 types of connection. One is with the microcontroller, you connect them directly to the output pin or output pin and input pin. That's it. You connect them directly. So the switch will be connected to the microcontroller directly, and LED will be connected to the microcontroller directly. The 7-segment, dot matrix, keypad, all will be connected directly. Your software here, which is also called firmware. Your software, which is also called firmware, will control them. You can monitor the switch and control the devices. So we have seen in the last 2 classes this. When you start doing a practical, you will know that you have to do lots and lots of problems. I'll give you a lot of problems. Start solving them. Then you will solve this switch. Okay, then goes to dot matrix. Then goes to keypad. That's the way it goes. So if you could able to make these 5 devices, then all other things are very easy. Whether it's a motor, whether it's a sensor, or all are easy. But you need to be very thorough with these 5 devices. The one advantage here is you have to write everything without the ready-made functions. That's a trick. It is very easy to use a function called out display 7-segment. You need keypad. It's all very easy. Okay, but that is good also, but sometimes you may not be able to understand that at all. If you do like that, you will never have a thorough understanding of the basic microcontroller operation, which is expected by the companies. That's it. Also, it's good for you to understand that. Understand now. Now let us talk about this one. First of all, as we discuss every time, we take only one port in the microcontroller. 8 pins. This microcontroller 8 pins has 3 addresses. 3 addresses. Understand? One is out. Okay. One is out. One is in, one is direction. So if I say a port, and as I mentioned repeatedly, a microcontroller can have n number of ports. It can have n number of ports. Need not be only one. That means that you can connect so many devices and so many things. It's a beauty of this microcontroller. Now, whatever chip we are using, that Atmega 2560. Why I've selected was it's available on a simulation, so you can able to see. I can show you everything in a very clear way. That's why I've chosen this. But all are same. The same code works on every microcontroller. It doesn't matter. Now, we take that day we took one port called port F. Port F in is 0x2F. Out is 0x30. Sorry, 31. Direction is 0x30. This is a port F. Okay, port F. Each port have like these addresses that I've shown you on the data sheet. We'll see once again data sheet after some time. Now we use port K as an input, and let us use port F as an output. Understand? That's a trick. Now, this we take only one pin. Forget about the other pins. Other 7 pin, we don't use it. We use only one pin, bit number 0. I connected that to the ground, one LED resistor. That means that this key will be always 0 volt. This pin will be always 0 volt. So what we do here is we connect a switch, a push button switch, and this pin you connected to 5 volt. This you connected to 5 volt. Understand? We have a push button switch. Looks to be very simple, but if you learn this, you learn the entire microcontroller. They'll be very surprised. If you learn this input and output, that is what electronics. If you start doing the experiments on this, and if you are very comfortable with this, then you can do wonders. There's nothing great, nothing great. Here also, we don't use the remaining 7 pins. We use only one pin, bit 0. Other pins I don't use. Let us say I have 8 pins, up to 7. So 1 to 7 I don't use. 1 to 7 I don't use. I use only 1 because we are going to use temporarily. I connect a resistor, the LED resistor, to limit the current and drop the voltage also. 3 volts and 2 volts. So it will divide the voltage. Also, it limit the current. So if you give a LED, they say that 10 milliamperes. If you give more current, then the LED will burn. Same way, port K has 3 addresses. So what are the addresses? Port K has 3 addresses. In 0x106. Out 0x108. Direction 0x107. So understand, these are all the names for, like how you have been given a name called Balaji. I have been given a name by parents. Like that, this microcontroller manufacturer has given a name for each port. Don't ask me why they are given this. No. It is internally they have a decoder or select logic, and they selected the address. Like how we have our parents selected. A name is combination. Like that, this chip parent is Atmel, the company. Those engineers have selected for every port the addresses, and you don't know what is that. That's the reason they have documented it. They've given you a book called data sheet. You have to refer the data sheet to know what is address. Okay. So that, let us see a minute. I don't want to take more time because we already discussed previously, but still I wanted to show in a minute that one to refresh your mind. Okay, to refresh your thing, I'm just giving you the. Now go here. This is a data sheet at Pega 2560. Am I right? Okay. This is a data sheet. Now, if you go to the content page, I'm not worrying about other things now. I'm worrying about IO ports. In the IO port, I'm going to register description. Am I right? See port A. What is address? Port A 22 is out. Data register and direction register 21 and 20 is called input. Port B 25, 24, 23. Port C 28, 27, 26. Like that, every port they have address. We are using port F. 31, 30 and 3F. 31 is out. That's all I've written here. And 30 and everything. Same way, port K we are going to use. So first of all, you should write this. If you don't know this, you cannot write a program. Now let us write a program. Let's try to understand what I'm writing now. So let me connect it on a board, and I'll show you. I'll share the screen, and let us go to the simulation. I hope you are able to see my screen. Okay, so I'm taking the Pega because that has a lot of ports. It's better to use that. So understand now. Okay, I'm not using the top one. I'm using only these ports. This is port. This one is port F and port K. I use only one pin. Now I take the LED now. Let us say I add a LED plus LED connected here. Now LED is anode. So cathode. I have to connect to the resistor. Okay. So let me take a resistor now. Let me take a resistor. Add resistor. Done. So now what I'm doing, let me put it slightly away. So easy for us to remember. So what we have done is we have from the cathode, I connect to the resistor. Done. So the connection is done. Now from here, I connect to the ground. Same thing, if I connect it from the ground, it will become nice color, black color. Okay. So you'll be easily understand that. Now this LED other pin, anode pin, I connect it to the first pin. As we mentioned, port 1, first pin I'm using. Done. So this is port F, first pin. If I write the program here, I think you are visible. If you're not visible, let me know. Dir F. I'm giving a direction. Then because I'm going to use only out. So no, this I'm not going to use this as an input port. See, please understand this connection, whatever I'm using the port I'm giving here. And why I'm using character is all 8-bit. This is a 8-bit microprocessor. What we are using is a 8-bit microcontroller. So I'm using CHAR. CHAR means 8-bit. Okay, now what I do here is, I say, first of all, I check now. I don't write a big program, I write a small program. DARF is equal to 0x30. That's as per the document. As per this document, see here, as per the document I'm taking. DARF. See here, F is 30. I can make it bigger one. All right, you see here now. Now you see bigger one, that is 30. Okay. 30 is the address. Don't worry about the bit address. This is called bit. That's for different purpose. We don't use it right now. Okay, that is for bit addressable. That is not supported by C. That is not supported by C. That's why I don't use it. We use this. This is called, that's what you may call that some embedded C and all. Forget about that. So 31 and 30. So 30 is for direction F. That's why you could see this program now. Am I right? You see the program I've written, 30. Now out F is equal to 0x31. Once again, the document. See, always make sure that you refer the document. If somebody asks you that, how did you get 31? You should tell them that I referred the document. I got the data sheet. Okay. So by heart, sometimes I know even a page number. That's why I do that. See here. Now we have done. Now we make sure that the connection is working or not. So what will I do now? I write a small thing here. Okay, star. First I have to change the direction. Start DIRF is equal to 0x01. That means that I'm making only one bit as on. Then I put star out F is equal to 0x01. I'm making the bit to be on. So in the direction I'm setting as output. Setting as output. And here LED on. Don't get confused both. Now, by default, all the ports are input ports. Okay, by default, all the ports are input ports. That's it. Now you see, I run the program, the LED should glow. If it is not glowing, we should know why. We should find out why it is. Yeah, now it is glowing. Am I right? You see that now. Okay, I hope it is visible. Now, understand one thing. We have done a port output. Now I'm going to connect the input port. What will I do? I add a switch. I add a push button switch. And how the switch work? Go there and click that question mark. Click the question mark. You will get to know the configuration here. See here? They have L1, 1L and 1R are connected. 2L and 2R are connected. They are internally shorted. But in between, there is a switch. That means that if you put a switch, 2L will be connected to 1L, 2R will be connected to 1R, and all the two rows of one row will be connected. Understand now? And they've given you that how to change the colors. Right now, this is green. I can change the color as a red or whatever it is. You can make so many colors. For example, I'll show you the thing now. How do I change the color? Please understand. How do I change the color of the switch? Go here, JSON, and say here, color red here, attribute. Now, this guy is green. I change here to red. See here, red, blue. That's it. Now, see here, the LED. This is LED file. See, LED 1. That I can change the color to green. See, it become green. So you can change the colors as you wish. Don't worry. Now, what I'm doing now, since already I have shown that 1L and 1R are connected and 2L and 2R are connected and in between a switch. So what I do now, I once again take a resistor. I'll tell you why it is, why the resistor is required. I take a resistor, connect it to one R. Sorry. So I connected. Now this wire, I connected to ground. Understand? The same thing which I shown you on a diagram, I'm doing it now. One resistor, whatever in the diagram, I'm drawing it now. Am I right? Now it's connected to ground. Now what happened? The same pin which is connected to ground, it's also connected to the port K1 pin. So I've connected to the port K. So I'll show you the same thing on the diagram, then you will understand. Then I connected the other pin of the switch to the power, 5 volt. So a switch has been connected with the power and the thing one. Now, when I press the switch, I want the light to be on. Am I right? Otherwise, it's off. Let us see that. Let us write a program now. Now, first of all, we have to say the port. We have to declare them. I declare now star DIR K, because this is a K port. This is AF port. Star in K, because we are going to input. Okay. And here, same way, DIR K equal to 0x0. I make here say input. 0 means input. Then out, say in K is equal to, sorry, not 30, not 0. It's 10. Direction is 107. And input is 0x106, which you remember once again. Once again, I'm telling you repeatedly because I'm not assuming things. I'm taking them from the data sheet. Now port K is here, HIJK. You always get confused how I get the numbers. You should know that I get the numbers from the data sheet document given by the company. 106, 107, 108. 106 is input, 107 is direction, 108 is output. Why I'm repeatedly telling you is that a lot of people get a doubt here. Now, direction, star direction, is 0, 0. I make everything input. And here, star out is a in. Now we have to input. Now I'm not going to do the LED on. See here. What I'm going to do now, think of a minute. While 1. While 1 means always in the loop. While 1 means always in the loop. What I'm doing in the loop, I'm going to do that. I'm going to read X is equal to star in K. But X is not declared. So I put here volatile character X. I've given a X also variable. So I'm reading the X now. Now, what I do here, if X and 0x01, I'll tell you why it is, why I'm doing that. I'm checking only one bit because I've connected only one switch. I connect only one bit equal to 0x01. I'm checking that bit is 1. That means you pressed. When you press it, I get 1 here. What I'm doing here, star out F is equal to 0x01. Else star out F is equal to 0x00. Out F means output port. So F is the output port and the K is the input port. Now I'm reading the K, checking the bit. If it is 1, I will explain to you what is this function, why I'm doing this, and I'll tell you that. There was something you should know that. Okay. So these things, if you have a doubt on this first 5 lines, ask me now. If you have the doubt on the first 5 lines, ask me now. What I'm doing is, I am declaring everything volatile because this guy, I'm telling the compiler don't optimize because I'm reading from the port. Then I'm always setting the addresses given by the data sheet. These are all addresses given by data sheet. Then I am setting the direction as a output and input. Only one bit. One bit 0. See here. Then what I do here is I do X is equal to in K, I'm reading it. Then I check only that bit. I'll explain this on the board. Okay, otherwise you'll have a small doubt. Now I'll just run it. Otherwise, let's see that. There's no compilation mistake. It's fine. Okay. Now if LED is off because you're not pressed, it's 0. And when I press, LED is on. See that. This is a very simple exercise for switch. Yeah, that's fine. This compiler is fine. Normally takes care of it. That's fine. That other compilers take care of it. This compiler is not so strict on that typecasting. That we can do that. That's the thing. So right now, understand the principle. When you want typecasting, you can do that. But I think this compiler is not very strict on that. That's fine. Otherwise, everybody will get confused if you do too much of typecastings. Okay. So you understand now. So how I do that? See, when I press the switch, now I've written the code here. When I press it, when the switch is pressed, I make it 1, otherwise 0. You can do anything, not only one switch. Let's say when I press the switch, 2 switches to be on, 2 bulbs to be on. Then you can do very simple. Another LED connected here. Now we put 02. See, if you put 02 here, that will be on. It doesn't matter at all which is going to be on. Yeah, I will tell you. That's why I said I'll explain to you. We should not check that. That I'll tell you the reason. That is a mistake. Here, someone is asking that why I'm doing this ANDing, why I don't check directly. I'll explain to you right now. Okay. I'll go before that. I just want to do one more small experiment. I press the switch. When I press the switch, this pin is connected. See here. 1 minute. When I press it, you see here. That's why I shown you that. You put the question mark, you get a page. That page will explain to you that how that switch is behaving. See here. The switch is here. 1R and 2L are connected. So what I have done is, when the moment I press the switch, these two are connected. So what I have done in my diagram, I connected a 5 volt here. So when I press the switch, the 5 volt will go to the pin. I'll explain right now. See, you just watch this. I will explain on the board. Then you will understand. Okay. I will explain on the board. Then you will understand thoroughly. Now I'll just run the program. I put 02. See, this is, normally I want to show you the connection. Then I expand the board. You will be understanding better. Now you see here, I put 02. I press the button. Oh, sorry. See, now red is on. Now you can say that first time red should be on, second time green should be on. You can do that. You just add a program. Whenever you press the switch, increment the button and do the thing. Okay. Those things only we have to slowly increase. I will show you at the end of the class now. I'll do one thing right now. We'll go to the thing. I'll go to the board and explain to you that two doubts. There were multiple doubts. You can ask me, but there were 2 doubts were asked. I explained both the doubts. Understand? The first doubt is, the first doubt is very clear. In the pin, there are 8 pins. 8 pins in a port. You cannot read one pin. There are 8. You have to read all these 8 pins. If you put X is equal to star in K, and if you put here CHAR star in K is equal to 0x106. Of course, I use volatile also here. Don't forget to add volatile. If you don't forget, then you'll have a lot of doubts, lot of problems. Always add volatile. This is normally you never use it on your programming, but that's why in embedded interviews they will always ask you what is volatile. So I put 106. Now when I read it, I read the entire port, the 8 bits, 0, 1, 2, 3, 4, 5, 6, 7. Whatever the voltage will come to the thing. Here is a problem. We use 2 types of transistor. One is TTL, other one is CMOS. The problem with the TTL is based on current, and CMOS is voltage based. Because of that, it operates on very low current. So what happened when I use TTL, then the IC will draw huge current. So people have moved away from TTL to CMOS. But the problem with the CMOS is the voltage goes via a dielectric. That's called metal oxide semiconductor, SiO2. This acts as a capacitor. So when these are CMOS gates, FET, I'm talking about FET, forget about CMOS, FET. Now, when the pin is leave it like that, when you're reading the pin X, very unfortunately, this guy is a capacitor. What voltage that guy will have it, which will be that, the previous voltage. That could be 0 volt or 5 volt. That's why we call X all of them. We call all of the one which is not connected, we call all of them as X. So if you read, here you connected a switch. That's why what we have done here is, you cannot, see, I would have done like this, am I right? Why? See, there's a switch. I connect to 5 volt. A switch. When a switch is not pressed, I read 0 volt. When the switch is pressed, the 5 volt comes here. Am I right? But that is not true. That is not true. Don't do this mistake. When you connect a switch, don't do this mistake. When you leave a wire in CMOS, that can be 0 volt or 5 volt. It is not guaranteed. You should never leave a pin open in CMOS devices or MOSFET devices. So what we do here is, we connect it to ground. That's why in my circuit diagram, we connected to ground. This pin is connected to 5 volt. When I don't press the switch, this pin will be 0 volt because it's connected to ground. The moment I press the switch, the 5 volt goes here. It becomes 5 volt. That's why when I read the port, this gets changed into this bit. When I don't press it, that bit is 0 volt. When I press it, that pin is 5 volt or 1. So you understand? Do you understand that? That is a pin, if you connect it to ground, this is actually called pull down. If you connect the resistor to 5 volt, we call pull up. Why we call pull up is a wire which is not connected, maybe having any voltage. Okay. And especially here it is a CMOS, whatever the previous voltage that gave it may be retaining. Let's say you press the switch and release the switch. That 5 volt will be gone. That 5 volt may be there if you don't connect it. Let's say I don't connect a resistor. If you leave it, when I press the switch, I give 5 volt. When I release the switch, the 5 volt will be there. It's because this is nothing but, the input is nothing but a capacitor. That's you have to understand that. Please understand, you should never leave a pin open. Now, since in our connection, I left all the 5 pins are open. Here is 7 pins. The X, that means that when you don't press it, the switch, if you read it, you will get this bit is 0 because you connected to ground. But all the other bit could be anything. So if I check if X equal to 0x01, this will never be this condition, because the probability of these things has to be other voltage will be different. So what I'm doing is, to make sure that this bit has to be 0, I am ANDing with 001. When you AND with 0, this becomes 010, but all the other bits are. This operation is called masking. I'm masking the remaining how many bits? 7 bits. I'm reading only 1 bit. This is a very important concept. Please understand. These are all the very, C programming, but how I'm using it on embedded is very important. I'm reading only 1 bit. Now, when I press the switch, this become 1. Now I get 01. That's only I've written a program now. If X and 0x01. See that this operation, I do it here, equal to 0x01. Never do that. Never do this mistake of if X is equal to 0x01. Don't do this. This is a mistake. This will never work. Okay. But that will work when? I will tell you when that will work. I'll show you now. See that. The same thing, I'll show you the demo now, then you will understand. The moment I show a demo, you will understand. That's a trick. That's the reason I always show a demo immediately. Oh, sorry. Okay, now see here all the input pins, 7 pins. Okay, I take this pin. I take this pin, connect it to ground. What I'm doing now, I'm connecting all the pins to ground. Of course, if I have a time, I'll draw it very neatly. But since I don't have a time now, I just do it like just. Understand now? I've connected now. Now, if I do like this, if you remove this line, this connect. Now it will work because I connected all of them as a ground. Now I see that. See? Now if you remove them, may work, may not work, but let's assume that I remove them. I remove all the ground. I remove all the ground. Understand? Now I remove all the ground. That means only 1 bit is there. I don't change the program. I've written X is equal to 001. I run the program. Of course, this since I connected previously ground, that gate keep it ground, but that may not be always true. So that's sometime it works, sometime it does not work. You cannot guarantee that. So always do this. Let me connect the pin to the ground, and once See, it does not work. It does not work if the pin is other than 0 volt. Okay. That's the reason we make it the AND. Now the same thing will work if we do AND 0x01. See? Because I connected the pin to the 5 volt. Let us remove that. I remove this. Sometimes these things are simulation. They may consider as a 0. That sometimes you may not get it, do that perfectly on. Yeah, this they make it the pin as 0 always. That's why they consider to be 0. And now you understand. Somebody asked me that why we put the resistor and the 5 volt. That I have given an expression called pull down and pull up. This resistor connected to the 0 volt. That pin. The same switch pin is connected to the microcontroller. Okay. So that is, if you don't pull up that thing. The same way, why we are doing the AND operation. Now, let us write a program. When I press the switch once, first time when I press it, this should glow. Second time when I press it, the second should glow. Let us do the thing. So what I do here is, let me do that. Because this has to be done tightly. I press. I given a variable called I. Okay, let me declare here. Then I say I is equal to 0. Okay, I make I is equal to 0. Now what I'm making, whenever you press the switch, I'm incrementing the I. Am I right? Whenever you press the switch, I'm incrementing I. What I do here is, if I percentage 2, if it is 1, then I make it as a on. Else. You understand this? What I'm doing now? See how I'm effectively using the C. These are the advantages of C, knowing C. Now I'm offing the thing. See that? I on the LED, I off the LED. But based on I percentage reminder will be 0 or 1. If it is odd means I will on the LED. Even means off the LED. But I'm incrementing the I whenever it presses. Whenever you press the switch. Okay. Whenever you press it, you increment the thing and it's in a while loop. Now let me run the program. So 0 2. Second LED. Okay. So always this LED is on now. When I press it, see, this is not coming correctly. Am I right? See, you know the problem here. You're not watching. See, when I press it, release it, both are on, and see that. See that? What is happening now? See? It's not behaving as what we want is, when I do first time, press. See that? It's a very problematic. Both are on now. It can never happen here. As per the condition, it can never happen. but you are not able to predict. You are not able to predict the outputs. You understand now what is it? Why it is? Do you know why? This is because the processor is running at a very high speed, and you are very, very slow. So what we do here is, I will check here. I check here. When I press the switch, I incremented it. Am I right? I incremented it, but I'll be in a loop while. Okay. See, I'll explain to you on the board. 1 minute. See here, what I'm doing now, I'm making a small wait here. That means that once you press the switch, till you keep on pressing the switch, I don't. Oh, sorry. There's a bug. I'm not. Oh. Let me check 1 minute. Why it's not working? Oh, X is volatile only. That's fine. No problem. Then X and 0x01. I'm putting that. It's equal to 1. Correct. Then only it's coming in. Then I'm making it as a 1. Checking for 1. No, I is already assigned 0. I is assigned 0. I is going to be incremented every time, the loop. Okay, so the thing is that I'll explain to you on the board what I have done now. Okay, what I have done it on the board. Then I'll come back. After the board, I'll come back that. What I have done is that, see, the trick here is, when you press a switch, there is something called bouncing. You heard about bouncing. That is, because of the mechanical contact, you think that the 5 volt, this ground, you think that when I press the switch, I get here 1 always. No, that is not happening. Actually, what is happening is, this goes to high and low. Then finally, it'll step down to 1. That is, when you press the switch, this goes to high and low. Then finally, this is called bouncing. That if you want to nullify that, you should take care of it in a software called debouncing. How do you do that? The switch manufacturer will tell you that how much is the time, maybe 100 milliseconds or 300 milliseconds. The bouncing will be there. For that time, you need to be in a loop. And once you should come out of the thing once it is 0. Okay, you should, for example, let us see that here. You should have a loop. You should have a wait time. You should wait for the debouncing time that is given by the data sheet. After that wait, you should, here, I can give a small delay now. I'm giving a small delay. Let us remove the while loop now. Oh, I did a mistake here. Okay, let me see that. What is it? I put J here. Sorry. And sometimes I may also do a mistake. It's not called. See now. When I press it, that guy is changing. Because I've given a small delay here to take care of the debouncing. Initially, it was hanging. It was hanging initially because I was given a hint. I should have given a long. That is a mistake. So you press the button. If you don't have the delay, see that what is happening. If you don't have a delay, if you run it, see, you don't know what is going to happen. See that red is there. See, once again red has come. It is because you don't know how much time you bounce. That's totally random. But when you do the other one, when you give a delay here, see, it will go correctly. Understand now? So this is the way you can take care of the debouncing. I'll give you more exercise on that, how to do that switches, more switches thing. Switch is a very simple concept. The only thing is, two things has to be taken care. One is you must connect, rule number 1, you must connect a resistor to pull down. If you don't connect the resistor, either pull up or pull down, then the pin will not work. All the input pin, you should take care of with a resistor, please. Don't mistake that. That's very important. See, resistor, what I have here connected to the pin, it's very important. See here, it's connected to the pin. Second one, you must do the AND. If you don't do the AND, then you will not get 0, 1. The result will be faulty. Third, I have shown you, after reading the pin, you should give a small delay. Every mechanical switches, these are all called mechanical switches. All the mechanical switches have a problem of bouncing because all the switches are having a push button, also a spring. All the switches have a spring. When you press it from your hand, then the switch, when you use your hand to press it, the spring will be bouncing. Because of the few debouncing, you will. But once you take care of the three things, if you write a function called read switch, okay, which will do all the three, that is pull down resistor and the AND operation and this operation, you will be able to easily read. Then you can do any operation. Then afterwards, you can do wonders with the switch. So it's clear. So this, I'll share this to you. I'll save this as a file and share it with you. Really easy for you. Okay. Shared. Okay, so I have shared now. So you can have a look at them when you have a thing and try it out. And don't worry, I'll give you more sums and more videos on this. The switch and keypads are a slightly confused one. I'll even 7 segments, everything. I'll give you more videos than this. This videos is the class is the one thing. I'll try to release more videos. Once I do that, I'll release all the videos. So the extension of switch is called keypad. Let's have a small break for about 5 minutes. Then we will discuss about the keypad. Okay, so fairly only 5 of them. I told you LED, 7 segment, switch, keypad, and dot matrix. The 5 you master it out. If you do the master these 5 out, then you'll be fairly very good idea about the embedded. Okay, then you can go to the next level much easier. Okay, so let us stop the recording.